My name is Zachary Gotthardt. I am pursuing a master's degree, and my advisor is Dr. Laura Harris. I'm studying the effects of oxygen on photosynthesis and respiration in a polluted estuary. So photosynthesis is the process by which plants, or in my case, phytoplankton, convert carbon dioxide and water into simple sugars and oxygen. Respiration is the opposite of this process, where organisms higher up the food chain convert those simple sugars into carbon dioxide and water and get an energy source as a result. My work takes place in an estuary known as Rock Creek. It is a small tidal estuary downstream from Baltimore, and it is considered very eutrophic. When a system becomes eutrophic, it's experiencing too much nutrients. We start to see a lot of ill effects coming from this eutrophication. The water becomes more murky. As the water becomes inundated with all this organic matter, it has to eventually decompose, and this results in hypoxia, which is low oxygen, or anoxia, which is no oxygen whatsoever. In hypoxic or anoxic systems, we see a lot of problems with fish kills. Occasionally it can get so bad we start to see hydrogen sulfide becoming a bit of a problem. Hydrogen sulfide smells like rotten eggs. So there's a lot of interest in the Chesapeake Bay to understand the effects and the chemistry associated with eutrophic estuaries. In my study site, Rock Creek, which I mentioned before is very eutrophic, they installed an aeration system back in the 1980s. And this aeration system is designed to overturn the water column in an attempt to add more oxygen to the system. You can actually see the aerators from the surface of the water. They actually bubble up. We've been working very closely with Anne Arundel County, who takes care of these aerators, to determine when the aerators should be on or off. To measure the photosynthesis and respiration rates, I use what is called a photosynthetron. A photosynthetron is a box with a gradient of light, and the light is designed to mimic sunlight as closely as possible. We take sample water from Rock Creek and we place it into the photosynthetron and measure the change in oxygen over time. So by measuring the changes in oxygen over time, we can calculate what the respiration rates and photosynthesis rates are. In eutrophic waters, you see a lot more nutrients coming out of the sediments, which actually further encourage the phytoplankton growth. So it becomes this never-ending cycle. People want to see high oxygen levels in the system because it supports a more healthy ecosystem. It can support a more diverse fish community, more crabs and more oysters for people to catch, which is obviously what we want. And we just want to see more clean, pristine water. It's interesting in Rock Creek because this is a very unique opportunity to study the effects of oxygen in a eutrophic system, which would not normally exist in nature otherwise.